Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your question, and we'll try to get to as many as we can near the end of today's webinar. And finally, at the end of today's webinar, we also are going to be doing a drawing for 6 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 6 lucky winners. Okay, with that, we'll go ahead and kick off today's webinar, which is latency, #1 metric for your cloud. Our speaker today is Boyan Krosnov, who is CPO of StorPool. Boyan, thank you so much for joining me today. I hope everything is well on your end.
It's good, thank you. Hi everyone. So let's begin. I hope you all are feeling well in these kind of interesting times, right? So here's a bit about myself. I kind of a very long time ago I used to be a kind of competitive programmer, and later in my career I did some packet processing and things like that. And at StorPool, what I do is what we call external technology. I'm the kind of chief of product, and I talk to a lot of our customers and figure out how we apply our great technology to serve them in the best possible way, right? And along the same lines, I'm a cloud architect. I help a lot of our customers design complete kind of cloud architectures. Next slide, please. And so what is StorPool? StorPool is a fast and efficient software-defined storage system. It's used by private clouds and MSPs and cloud service providers, etc., and also by a bunch of kind of private clouds for mobile and web applications of kind of large scale, usually. We started in 2011 to solve storage for cloud service providers because at that time there weren't any solutions that were good for this use case on the market. And we started with a clean slate design. We've built the whole thing from scratch based on this requirement. And that's how, based on that clean slate design, clean slate implementation, based on that, we have some pretty unique properties, pretty unique capabilities in StorPool that are not available in almost anything else on the market. Next slide, please. Right, so most of StorPool's deployments are with the KVM hypervisor. So it's mostly used for virtual disks or virtual machines. And there are some deployments with Xen and some with VMware, but these are more kind of in our customer base. These are more often considered kind of legacy stacks that people are moving off of. And our solution is strongly associated with modern IT. So these are situations where there is automated provisioning or DevOps or automation, etc. Right? Some of the deployments are bare metal. Previous slide, please. Some are dedicated server, and we have deep integrations with OpenStack and Kubernetes, etc. Next slide, please. So here's the kind of the main topic of today's presentation. If you consider the performance of any transaction processing system, so that could be a load balancer or a web server or a database or a storage system, etc. There are many of these systems, and they all have pretty much the same kind of characteristic. And that is that when you increase the load on the system, you also increase the latency of the system to some degree. And next slide. you can see that if you have say 4 CPU cores and you have one task to execute, that task completes in a given amount of time, say it's 1 second. Next slide, next slide. And if you have 4 tasks, then these would complete in essentially in the same amount of time, minus some synchronization overhead, assuming there is any overhead between the tasks. And where this kind of beautiful model of slightly more work, slightly more latency breaks is, next slide, is when you add the fifth and the additional tasks, right? So the situation you end up in there is queuing or scheduling. And in that situation, not only would these 2 additional tasks become slower, also the original 4 tasks become slower because of a lot of kind of overheads that are associated with switching between tasks or scheduling. So what we ended up doing, going from 4 tasks to 6 tasks, is we increased the demand for a load on the system, but we didn't increase the system throughput. So it's still able to process only 4 tasks per period of time per second, and perhaps even lower than that because of the additional overhead. Next slide, please. So essentially, many systems all over your stack have a performance, so operations versus latency characteristic that goes something like this. There is an elastic mode, elastic part of that curve, in which when you increase the load, you also slightly increase the latency, but when you increase the demand, you also you get what you ask for, right? You get additional supply. There is a saturation point, and after the saturation point, there is a completely different mode of operation of all of these systems. And this is the mode where there are tasks or things or queries waiting in a queue, and then some of the queries are being executed, and then the system moves on to the next queries in the queue, and that's in the congested mode. And next slide. Generally, for kind of the best service, say you have a microservice or like a component of a website, the best end user experience, the lowest latency, the kind of the snappiest experience you would get at the low end of that curve. Next slide. And the lowest cost per delivered resource you would get somewhere slightly before the saturation point. And the moment you kind of increase your demand slightly over the saturation point, what you get is only pain. Kind of it's usually hard to run the systems close to the saturation point, and in order to achieve that, you need things like, say, auto scaling or something like that to keep your individual services or API endpoints, to keep them capable, to have enough throughput so that you don't ever go over the saturation point. Because if you do go over the saturation point, there are API calls, queries, anything, all these things piling up in a queue, and you don't get more work done. You get less work done than in the situation under the saturation point. And not only you get less work done, the work you're doing is with huge latency. And it could be infinite latency. So you could get a pile up and latency becomes really, really large. Next slide. And the kind of interesting part is that most benchmarks, so when people measure the performance of all kinds of systems, what they're thinking about, what they're doing is that they're putting the system in this end of the curve, in the top right end of the curve. And that's definitely not the part of the operation versus latency curve that you would be running the system in production, right? So you want to run the system in the elastic part of the curve, but when you execute like a benchmark, most benchmarks that you see published, most benchmarks that you run yourselves are putting the system in the top right end of the curve. Next slide, please. Yeah, next slide. Right, so we did an experiment to try to figure out how important latency is. And the way we achieve that is like we have a setup which is designed so that we are able to vary just a single parameter, and that is the storage latency. And next slide. The way we achieve that is we have one virtual machine with two volumes or two virtual disks attached to it. One virtual disk is delivers approximately 150 microseconds or 0.15 milliseconds latency for small I/O operations with queue depth 1. And we have another volume which is the same as the first one, but with about 2 milliseconds of added latency. The way we add that latency is this is a KVM virtual machine, and we add the latency with DM delay in the host. And this is only designed to demonstrate what happens if you modify just that one single parameter. I wouldn't recommend anyone use DM delay in a production environment. It's just like an experiment or a measurement tool. So both of these virtual disks are on the same storage system. They're on the same pool, and both are on purpose limited to about 20,000 IOPS per second flat. And this is in order to kind of eliminate some of the kind of variability in testing. So here's how it looks on that same diagram. So the throughput of these virtual disks is 20,000 IOPS. Next slide. And the latency for kind of the beginning of the curve for one of these volumes is 2 milliseconds. Next slide. And the beginning of the curve for the other virtual disks is 150 microseconds. And this is the only difference between the two. It's not even an identical virtual machine. It's the same virtual machine that we are performing these tests on. Next slide. So this is the benchmark we're running. It's like transactional processing benchmark that in this case has 16 parallel 16 clients, 16 database clients on 8 threads, and the database size is 4 times the size of the memory of the VM. So it's like 64 gigabytes database on a 16 gigabyte VM. And the way these parameters are designed, it's not random. It's selected based on the recommendations of PostgreSQL. There is a page on their wiki which basically tells us what is the best way to measure the real life performance of a PostgreSQL database. Right. Next slide. So on the virtual disk that has 2 milliseconds latency, what we're getting is 1600 transactions per second at 8 milliseconds latency. This is database transaction latency, right? So it has nothing to do with the latency of the storage system underneath. It's kind of the application or platform latency. So if we ask this database to do 2500 transactions per second, what you'll get is a pile up, and the database is not able to process that many transactions per second, and you get more and more and more latency because there are more and more transactions coming in, and you can't process them all, and they end up on a kind of huge queue waiting. Next slide. And if you only change the latency of the storage system from 2 milliseconds to 0.15 milliseconds, you end up with same benchmark. You don't change anything in the benchmark. You end up with 3600 transactions per second. So this is about 2 times more at 3 milliseconds, which is about a third the latency of the original test. And if we ask this database, so it's kind of same VM but just on a different storage. If we ask this database to do 2,500 transactions per second, it's absolutely happy to do these transactions. I have this recorded on a video which you can find on YouTube if you search for latency and my name, and it will be pretty easy to find. So I have demonstrated this a couple of times live for this webinar. We decided to skip that. So what does this tell us? So this experiment essentially shows that on the same compute resources, if you have a faster storage system, you get more work done with the same amount of compute resources. And a faster storage system also makes some things possible, while other things are kind of on a slower system. The same thing would be impossible. And it also tells us that virtual disks that have the same headline specification. So if you have two virtual disks and one says it's 20,000 IOPS per second and the other one says it's 20,000 IOPS per second, this is still not enough for you to judge how good these virtual disks really are for a production application. And the reason that it's not enough is that you need to understand the kind of the latency characteristics, especially latency under load of these virtual disks, right? Next slide, please. So what we did is to kind of try this at large in some real public clouds and compare that to a private cloud environment, our private cloud environment, which is also built with StorPool. So StorPool is kind of, we're also our own customer. We eat our own dog food, and we have two clouds which are at reasonable scale, and we use ourselves using our own technology. So we took very, very similar VMs from AWS and Google Cloud and Microsoft Azure and DigitalOcean. These VMs are with 8 vCPUs and 16 gigs of RAM. And we did the same with our own private cloud environment. You can see there kind of the 12-month, if you commit for 12 months, what kind of price you can get without negotiating. This is straight from the price list. You get something like 160 at the low end of the scale to $240 per VM per month for a VM of this size, which is not large, right? It's just normal VM. And the only special thing here is that in Google Cloud, their standard general purpose VM has 32 gigs of RAM. And the way we adjust for that is we allocate 16 gigabytes of this memory in a large file in a temporary file system, which is a kind of RAM disk in memory. So in this way, we have 5 VMs which are very similar to each other in terms of compute resources that they have. They all run on Intel CPUs. They're running on pretty similar frequencies as well. There may be like a 10% differences in the frequencies, or say even worst case 20% difference in the CPU frequency of these. Next slide. And in each of the clouds, we got a block storage service. So this is like a virtual disk, which is about a terabyte, which is 1 terabyte in size. And the reason it's a terabyte in size is that in some of these clouds, Amazon and Microsoft especially, the size of the virtual disk drives the IOPS you get from that virtual disk. So in Amazon, even with a 1 terabyte virtual disk, you're still only getting 3,000 IOPS, and this has some effect on the performance you get in the end, which I'll show you in the measurements we did. So the first one, the virtual disk in the StorPool cloud doesn't have a price because we don't have like internal pricing, but we estimate the total cost of ownership of that virtual disk is about $50 or $60 per terabyte per month. So this tells you that in a private cloud environment, your internal cost to provide that same service would be about half of what you would in a public cloud. Next slide. So this is the So remember, I told you public clouds mostly publish kind of an IOPS specification for the volumes they provide, or the virtual disks. They wouldn't tell you you should expect 3 milliseconds of latency on IO operations you perform on this virtual disk. So the only way around it is just buy the service and test it. And this is what we did. So in DigitalOcean, we got about 3 milliseconds for random read writes with QDepth1, 4 kilobyte. In Azure, we got about 8 milliseconds, and out of what we see on the screen, the conclusion we can draw is that DigitalOcean is much better than Azure. It's possible there is some variance in these numbers, but they're always in this kind of range. And it would be a good conclusion if we didn't have the numbers for the other clouds. So next slide. So Google Cloud is like 700 microseconds, and AWS service is about, gives you on the same kind of measurement, gives you 360 microseconds. And next slide. And the StorPool private cloud gives you 130 microseconds latency for random read writes. So this, and I also have this graphically. Next slide. You can see how kind of big that difference is. So on a kind of well-designed private cloud environment on NVMEs, you can get extremely low latency compared to some of the public clouds. And the differences are several times when you compare that environment to AWS or Google Cloud. And next slide. And about 60 times when you compare it against a public cloud that doesn't design for or doesn't have the latency characteristic of the virtual disks nailed down. Next slide. So if we have such huge differences in the latency of these virtual disks, let's try to predict how that affects application performance. So this is one result we got. And on here you can see it's again the pgbench test with a database which is larger than memory. And on the StorPool private cloud, you get this kind of transactions per second versus latency characteristic, which means that if you ask the system to do 2000 transactions per second, it will happily do them at a millisecond and a half. If you ask the VM, which is on Google Cloud, to do 2000 transactions per second, it will happily do them at about 3 milliseconds latency, which is twice as much time as on the StorPool private cloud environment. And if you ask the AWS VM to do 2000 transactions per second, it will not be able to do them. And so next slide. I'll explain why it's not able to do them in a second. The other two competitors here, Azure and DigitalOcean, they're to the bottom right, and it's kind of the storage service they provide, even though it delivers a high IOPS number, is not good at all for transactional workloads such as databases. Also not for a kind of a large category of real world workloads. So it's not just about databases. So this is what, remember kind of the diagram I showed you in the beginning. This is kind of a perfect picture of that, right? So we didn't draw these points by hand, right? We measured them with a benchmark on a public cloud. We did some averaging, so we ran them a few times and averaged. And essentially what this tells you is that on the Google Cloud service, if you want, say, 2000 transactions per second, you can get them, and you can get them at about 3 milliseconds latency. And if you want that from the AWS disk, you will not be able to get them I believe the reason this is so low is not on, is the low IOPS of the AWS volume. So generally speaking, it's not 100% because it can't be reduced down to just these two numbers, latency and IOPS, right? Generally speaking, the IOPS capability of this virtual disk, which is only 3000 IOPS, determines how high that line is, right? And the latency characteristic determines where this line starts. So if you only have 500 transactions per second, the AWS service will be faster than the Google service. But if you have 2000 transactions per second, you will need to buy a larger virtual disk, or you need to buy like a much more expensive storage service from Amazon to achieve that, right? Next slide. And the other thing you can do with this kind of measurement, when you have this measured for different load levels, so for different levels of load, you know how many, like how much time does each transaction take, right? Another thing you can do is you can determine for a particular level of load what kind of latency you would get by drawing a horizontal line and figuring out where your load versus latency characteristic crosses that line. Next slide. And that tells you that in the StorPool-based private cloud, you would get a millisecond and a half, and in the Google Cloud VM, with the particular parameters, obviously, you would get about 3 milliseconds transaction latency, right? Next slide. So we have a bunch of these, so it's not just the Postgre measurement. We have done a few other benchmarks. For some of these benchmarks, it's not, storage latency is not that important. For others, it's extremely important, and this is one of the benchmarks which is very sensitive to storage latency. And this is if you have like 3 million files and you want to resync them. And this, an example for this would be a large software repository that you are extracting or resynchronizing using Git or rsync on a build server, for example. So if you do git pull, you would get something like this. If you do an rsync copy over an existing older copy of the source, you would get something, a workload which is very similar to this one. So here lower is better. And this tells you that if you have a private cloud which is on a low latency storage system, you can do this work, you can do it in a minute. And if you have a cloud environment which is on a not so fast, on a slower, higher latency, that means storage system, you can do the same work, not in 1 minute, but in 20 minutes, right? So 10 minutes is somewhere around here, and this is about 20 minutes. So that's 20 times more time waiting for a particular, say, build to be performed, for example. And this is my next slide. So key takeaways from what I've presented. The IOPS specification of a block storage service is absolutely not enough for you to figure out how good that block storage service or storage system, say if you buy a SAN or an all-flash array, it's not enough for you to tell how good that system is. Latency is a lot more important. IOPS is obviously important, but once you have millions of IOPS, then latency becomes the most important metric. And it's much more important than most people think. So everything else, even everything else being equal, by changing the latency, you dramatically change the performance of the application that's using the storage system that runs in VMs or containers, or yeah. And on this front, on the latency front, don't listen to promises. Do your own measurement. And it obviously depends on a lot of factors, so it will be different in different environments. And finally, consider working with vendors or technology partners who understand performance. Kind of the reason behind that is if you have a storage system which is fast, meaning low latency, you can do a lot more with your compute resources. In a private cloud environment, a faster storage system means doing more work with the same amount of compute, right? And StorPool is a company that specializes in this field, and we are quite good at it. Next slide. And we are open to questions here, and I think at the same time we will launch the poll.
Yes, we do have two polling questions that I'm going to go ahead and send out. Here comes the first one to you right now. The first question is, have you heard about StorPool storage before? Quick yes or no. We'll give you guys a couple seconds here to go ahead and make your selection. And while you're doing that, I do want to remind the audience that if you have a question for Boyan, please go ahead and use your GoToWebinar control panel and submit your question, and we'll try to get to as many as we can. I think we have plenty of time for questions, so I don't expect that that we will run into that issue of not being able to get to all of them, but
Yeah.
maybe we'll get lucky and have too many questions that you can answer, but we'll attack that when we need to. We'll go ahead and close this poll now, and then I'll push out the next one for you. It is coming out to you right now. That polling question is, are you actively searching for a new storage solution? Yes, within a year, yes, within the next 2 to 5 years, or no. Go ahead and make your selection. And then once we get started, or once we get all of the submissions for this one, then we'll go ahead and get started with the question and answer period. So let's see. Okay, it looks like we'll give you guys about 5 more seconds here, then we'll close it out. Okay, I'm going to go ahead and close the poll now, and we'll get started on those questions. Here's a question for you. How can we benchmark NAS storage in public cloud?
Oh, sure. So you would need the way I would approach it. I would start with determining what performance characteristic of that system I'm trying to understand. So kind of the naive way of doing it would obviously be find a benchmark, run the benchmark on the NAS system, and get some numbers and determine, that gives you a number. But the question you really want to ask is, what are the tasks, the actions that I'm performing on the NAS system, and ideally your benchmark should replicate these tasks. For example, maybe a common task for you is you have a large Docker image or tarball, and you want to see how long it takes for that image to get deployed, which means extracted on that file system, for example. Or maybe a task for you is you use that NAS system to store images, and you want to know how many images per second you can retrieve from that, and you would design your benchmark around your actual use case. And this would give you a result that's a lot closer to a result that is close to what you need to know, which is how would your application perform on the particular system. Yeah, I would do that. Okay. I would start with the application and the tasks that I actually need to accomplish.
Okay, all right, great. Next question here. Let's see. We have a high throughput requirement with NAS storage in public cloud for our HPC workload, around 500 megabits per second. Our SMB client, wherein clients can range from 1 to 1,500 users, accesses the same SMB mount point. How can we get such scalability in terms of file storage in the cloud?
Yeah, okay. I'm not an expert in that field, so the systems we provide, they are mostly for private cloud. But generally speaking, you would need a scale out file server for that use case, meaning a file server that can have an active scale out SMB target or SMB server in it. And these will be some specialized solutions. I'm hesitant to mention any of these solutions because I don't know them. Like I can't recommend any one of these solutions. Right?
Okay. All right, great. This next question, I'm not sure, actually, based on that answer, I'm not sure if it's one that you'll be able to answer, but let's see. How do you have a competitive advantage over NetApp or other NAS vendors? What secret sauce really sets you apart?
So StorPool is a block storage system first. So NetApp usually plays in file storage, not block storage area, right? So how does StorPool have a competitive advantage against NetApp? It's in the same way we have a competitive advantage against all the legacy storage vendors. Firstly, it's a software-defined solution, meaning you deploy it on standard servers, and that brings with itself a large list of advantages, including things like much better lifecycle management. So these are standard servers which you retire when you retire your standard servers, and you can kind of without stopping the application, you can move your data to the next generation servers. And secondly, when you have a system that is scale out, meaning it's composed of a number of servers instead of being a dual controller architecture like the NetApp storage arrays are, except for a single product, right? Then you get very different scaling characteristics. For example, when you add capacity to a StorPool storage system, you also add performance to the system when you add a storage node. Thirdly, when you have a storage system which is designed and optimized for low latency and performance from the very beginning, and it's not designed for with some other kind of top priority in mind, right? Another top priority might be data management is the most important feature, and we focus the design of the whole solution towards data management, which is probably what NetApp did in the early years, right? So when you have a solution that's designed with this goal in mind, the outcome is also very different. So the internal architecture of StorPool is very different from the internal architecture of traditional storage vendors, and also from the architecture of most software-defined storage solutions. And this difference of architecture and difference of implementation, the way we designed it, the way we implemented it, sets us apart from our competitors. And the competitors are traditional storage vendors like NetApp and Dell EMC, as well as software-defined solutions, other software-defined solutions other than StorPool.
All right, great. Got plenty of time for questions, guys. So if you do have one, go ahead and submit it. Next question. Object-based storage like S3 performance depends on object size. How do you measure data object size versus performance?
I'm not sure I understand the question, but I'll give it a shot. So,
okay.
How do you measure performance versus object size? Well, you could, in your benchmark, you could create objects of different size and measure how long does it take to create 1,000 objects of a particular size versus 1,000 objects of a different size. And this would only matter to you as a user of that object storage system. It would only matter to you if you actually have objects of different size. So if all of your objects are 2 megabytes because they're pictures, like photos in a particular format, for example, then you wouldn't care about how the underlying system performs under different object sizes. You would only care how it performs on your particular object size, right? So again, I think the kind of the most important thing here is try and design your benchmarks in a way that that is as close to the actual application you're going to run on these systems, instead of being synthetic, instead of being completely different from the actual workload you're going to put on these systems. And I'm sure, I'm not familiar with these tools, but I'm sure that there are specialized tools for measuring performance of object storage, and I would caution you about the same thing. Be careful about making sure that the test, the benchmark you're performing is with a workload which is similar to your production workload. Otherwise, you just get a number, and that number doesn't really mean anything, right? It doesn't tell you if the system is good for your workload or if it's worse, if it's better or if it's worse.
Okay, all right. Great, great. Next question here. Let's see. If latency is metric number one, what's the next most important? What's number two?
Yeah, yeah. So if latency is your number one metric, the next most important would be throughput. So if you're looking at kind of performance characteristics, we think in 20, well, there are a lot of, it's a complex environment, and there are a lot of solutions on the market, and different public clouds, each of them having different offerings, etc. So it's hard to generalize this much, but in 2020, most of the servers or networks or systems you get have way more throughput than you actually need. Meaning there is enough throughput for your application, and the only differentiator then becomes latency. However, there are still cases out there in the market. There are still offerings in public cloud, as well as say storage systems or other transaction processing systems, which actually don't have enough throughput for your workload, right? So it's also important to have enough throughput from performance standpoint. And if you look beyond performance, there are many other aspects to this.
Mm-hmm.
For example, one aspect is service. When you work with a vendor or a technology partner, what kind of support or managed service can you get from them? What is the quality of that service, for example, right? Is your vendor someone that you can rely on, and who is essentially an extension of your team, like a transparent extension of your team? Or is your vendor someone who you are fighting with constantly because you open a ticket and they don't respond for 2 days, right? So it's a very different user experience from one type of vendor to the other.
All right. Okay, so guys, just a quick reminder, we still have probably about 10 minutes or so for question and answer period. So if you have a question, please don't hesitate, just go ahead and put it on into the GoToWebinar control panel, and we will do our best to get to it. Okay, here's another one for you. Except for latency and overall performance, which other criteria should a company consider when choosing a storage system?
Yeah, so storage systems, like a good framework, which I learned some 5 or 6 years ago. A good framework for evaluating storage systems is to consider their performance, consider their scalability, and consider their data management capabilities. So in each one of these, in performance, you have latency and throughput, and these are kind of so IOPS and microseconds. In scalability, you have a lot of things bundled together under that term. So these are things like scale out architecture versus scale up architecture. These are things like automated provisioning. So operation that adds to operational scalability. Automated provisioning of storage nodes, for example. There are things in there like API control and integrations, and being able to use that storage system as part of an orchestration. So say you use, for example, you use OpenStack, and being able to take the storage system and plug it into OpenStack seamlessly so that each virtual disk becomes a separate one in the storage system. That's also part of the kind of scalability or automation aspect of the system. And the third dimension is data management. So these are things like snapshots and clones. Being able to create offsite backups is also considered part of data management. Things like thing provisioning, etc., etc. So there are a lot of features and capabilities which are grouped under this term data management. And we in StorPool we aim for having all three in good measure. So having a storage system which is good at all in all three dimensions. It's not like a one-trick pony that only does performance, but it also has a lot of very good scalability and also very good data management. So these would be the three dimensions I would that we think are important when you evaluate a storage system.
Okay. All right. Great. Here's a good one for you. Does the store pool automatically duplicate objects across multi-storage nodes?
Yeah, so the way StorPool is a block storage system, so the way it works is you have a StorPool cluster which is composed of 3 or more storage nodes, and every piece of data is triple replicated across the storage nodes. So if you have, say, a 10-node cluster, it will still be three-way replicated. You will still have 3 copies of data, which means that in a 5-node or a larger cluster, you could lose 2 of the storage nodes and you would still have online access to all of your data. And when you get to that situation, which is full access to data, but with degraded redundancy, so some of the data would have 1 copy in that situation, the system can recover to full redundancy. It doesn't need things like, say, hot spares or anything like that. It uses the remaining free space, the free space on the remaining disks to recover to full redundancy, assuming there is enough remaining space, right? To answer the original question, redundancy in a StorPool storage system is achieved through replication across storage nodes, and there is no internal redundancy within the storage nodes. So the storage nodes are kind of they're very simple servers. They don't need any special hardware inside of them to achieve internal redundancy in the storage node. Okay.
All right, great. I think we have a couple more here. Let's see. Can you share some top results in terms of latency which StorPool has achieved?
All right. So one of our published benchmarks, which was done on a larger test environment provided by Intel. In that test, we showed 70 microseconds write latency measured inside virtual machines, which means that it's a StorPool storage cluster on NVMe's on 25 gigabits Ethernet, so there is really no special server hardware in there. And we run a kind of test workload inside a virtual machine. In that environment, that test workload was able to commit write operations in 70 microseconds. And compare that to kind of a more typical production environment, which is not so optimized towards performance, right? And it's just uses more common components, for example. In that more typical environment, you could get, say, about 100 microseconds for writes. So the 70 microseconds to put them in perspective, this is about twice as much time as it takes for the underlying NVMe devices to commit the write operation. So about half of this time is used by the underlying devices, and the other half is used by StorPool to do all the other things, which is transfer this data 3 times over the network, commit it to the underlying drives, signal to the initiator that the write operation is complete, and get that kind of complete notification up to the virtual machine. So there are a lot of steps that need to happen for a write operation in the distributed system to complete. And being able to do that in 35 microseconds is kind of quite amazing. It's almost no other storage system on the market is able to do that.
All right. Okay, great. Here is another good question for you. Do you have customers and partners in the US?
Oh, yes, sure. So there are several different types of customers in the US. We have a few customers who are kind of smaller public cloud providers. You can find them on our website. Just look through kind of the user case studies. And another class of customers in the US are from the so-called managed service provider group. And the difference between the cloud operators and managed service providers is that managed service providers don't just sell a virtual machine. They don't just sell the kind of compute resources and storage resources. They also sell a managed service around them. So it's more expensive, you can say, but also a lot higher value add, a lot more services you receive with the service. Example for this would be our customer in the States called IOPS. And there is a third class of customers in the States that are private clouds. So say, for example, there is a large website used for trading cars in the States. And the private cloud environment is using StorPool. So like kind of one of the beauties of our technology is that it remains hidden. It remains hidden within the layers. So if you, for example, if you go to the website of some of our public cloud customers, so some of them compete against Google Cloud and AWS, others compete against kind of the lower cost option like DigitalOcean. They compete against DigitalOcean, for example. If you go to their website, it wouldn't say StorPool there, right? So StorPool is a technology that in the public cloud case, it remains hidden within the public cloud operator. In the private cloud case, it's kind of the storage system that you use inside the private cloud, and your users don't need to know about it because it plugs into an orchestration system, right? It's not something that you're in the private cloud environment. It's not something that your developers need to know about. It's something that the people, the team that manages infrastructure cares about and knows about, but the users of that private cloud environment, they don't, right? It remains hidden inside the infrastructure.
All right. Makes total sense. So I guess the last question then is, if folks are interested in the product, how can they go about trying it?
So drop us an email at info@storpool.com, I guess. And the way we run POCs is usually on kind of physical hardware. And we can offer, say, remote screen share demos, or we can deploy a small POC cluster on our customers' bare metal environment, for example. And drop us an email at info@storpool.com, and we'll take it from there.
All right. All right, great. Well, fortunately, that is all the time that we have for question and answer period, but we had some really great questions. Thank you very much for those, to those who did submit questions. As I said, we had some really great questions come in. So also want to remind the audience that today's event has been recorded. So if you missed any or all of it, or if you just want to watch it again, you'll have the opportunity to do so. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. The webinar is also going to be living on the devops.com website, so you can always go look for it there. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. Okay, without further ado, I want to go ahead and do the drawing for the 6 Amazon gift card winners. So let's see who our lucky winners are today. Our first winner is Claude N. Congratulations, Claude. Our second winner is Dave A. Congratulations, Dave. Our third winner is Ryan S. Congratulations. Our fourth winner today is Walter B. Our fifth winner today is Scott A. And our sixth and final winner today is Matt C. So congratulations to all 6 of you. We will be reaching out to you via email to get your Amazon gift card over to you. So please check your inbox. If it's not in your inbox, please check your spam folder. Okay, Boyan, thank you so much for such a great presentation. Lots
Thanks,
of
everyone.
really interesting information, and I know the audience got a lot out of it judging from the questions that came in. So thanks again, I really do appreciate it. I also
Thank you.
want
Yeah.
to, I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody. Please stay safe.